Good day, Grade 7. We will now start with our second lesson, which is earthquakes, second geography lesson. I am now on page 76 of your textbooks. Here, once again, is a nice map where they show us the location of most earthquakes we find on Earth. Like we discussed in the previous lesson, we know that most earthquakes we find along the borders of the tectonic plates, which we call fault lines, right? For the main reason that the main cause of earthquakes are these plates gliding past each other, like we discussed when we talked about the tectonic plate movements as well, right? But before we get to that, it's important to know there are two possible causes for earthquakes. I'm not talking about smaller earthquakes which can be caused by mining activity. If you look at certain places in South Africa where we have platinum and gold mines, where they mine deep kilometers into the ground, there you can have localized earthquakes because of blasting in the mines. But proper earthquakes can only occur because of two reasons. First of all, can because of volcanic activity. If there's a volcanic eruption, the earth can shake, right? But these aren't your major earthquakes. These are mostly smaller on scale. And then the rest, which is also includes your major earthquakes, is because of tectonic plate movement, right? Like we spoke about as well. Earthquake occurs when two tectonic plates glide past each other, like it's constantly doing all the time. Even while I'm talking now, plates are moving. But like as we know, these aren't smooth edged plates, right? It's rocky and bumpy, and it's not necessarily fits. So when it glides past each other, a lot of times it can get stuck because we're talking about pieces of rock and pieces of earth. So when it gets stuck, the tension starts building up because now it can't move as smoothly as it used to move. And then eventually one of the pieces breaks off and the tension gets released as shock waves. And these shock waves are what we feel as earthquakes, right? So an earthquake is basically the shaking of the earth, shock waves that goes through the crust of the earth, and we feel it as shaking of the earth. We measure these earthquakes with something called the Richter scale, as it explains to you at 1.1 there on page 76. Now, this scale was invented specifically so that we can compare different earthquakes with each other. If we say, for example, it is a number 2 on the Richter scale, we know it's a very small earthquake. If it's a 5 on the Richter scale, we know it starts getting bigger. And when it gets to 9, it's basically as big as it can get, right? That is a major, major earthquake where cities are being destroyed and stuff like that. Okay, if we have a look here on page 77 of your textbook here, you'll see there's a diagram where it explains to you exactly how the earthquake starts and what we call the different parts of the origin of the earthquake. The hypocenter, excuse me, is the place inside the Earth's crust where the earthquake starts, right? Remember, these tectonic plate movements doesn't take place on the top soil of the Earth. It takes place deep in the crust of the Earth. And this is where these activities happen, where the plates move and catch and release and sends out these shock waves. It's inside the Earth. Now, the place where the earthquake starts, we call a hypocenter. But the place where we feel it first is called the epicenter. Now, this is very important because we don't live inside the earth, right? We live on top of the earth. So you will see when there's an earthquake on the news, they will ask, where was the epicenter? They don't ask where did the earthquake start, because then they have to give you a location about 2 kilometers below the surface of the earth, which doesn't mean anything to us. What does mean something is if we ask where is the epicenter. Now that means the place closest to the origin of the earthquake on top of the surface, right? That is what we call the epicenter. So the hypocenter is inside and the epicenter is on top. Once again, it's important to know the epicenter because that's where we stay. You'll see also on this diagram, it shows us the seismic waves, excuse me, of the shock waves, how they move out in concentric circles. Now, concentric means it's the same size, growing larger and larger. So the same thing if you were to drop a penny into a pool or a small rock, you will see the ripples go out in concentric circles, right? So if you were 5 kilometers from the earthquake, all around you would feel it the same, and closer and so on. This is a very important diagram here on page 77, and this is also something that you need to copy into your textbooks very neatly with a ruler and with color and with all the words we find there. Please make sure that you copy this properly into your exercise book. It's a very important diagram. But now, it's one thing to know about these earthquakes, right? I mean, sure, now we've spoken about it, what about it? Now it's important for us to discuss the effects that the earthquakes will have on us as humans. That we will discuss on our next lesson. For now, it's important now we discussed earthquakes, what they are, where they start, why do they start, and also the diagram of the important information. Thank you.